All right, welcome back, Logan, to this last installment of Math from Your Couch. This is for the next module. It kind of just leaves off where we were talking about factoring. So what I'm going to do is I'm just going to leave it up here. This is basics on factoring. If you don't know how to do this, take a look at the last module's video, module 20, and that should help you out. So what we're going to do is we're going to use this idea, this premise, these problems to form our next problem. So that's what we're going to do is let's make our next problem. So we have 12x to the fourth. So we're going to say this is problem number 1, 12x to the power of 4 minus 60x to the power of 3 over x to the power of 2 plus 3x minus 40. Now, if you remember the problems from the last module, all you got to do is factor and then simplify. Now, why do we want to factor this out? So I'm going to look at problem number 2, and it's just all it is it's a fraction, and it's how we simplify fractions. So what if I had two fractions? Sorry, not two fractions. What if I had two numbers of a fraction? Let's say I had 24 over 18, and I'm trying to simplify this here. Now, I'm going to try to teach it as if you have never seen how to simplify a fraction before. And the way it works out is you want to factor it. So what is factoring? I'm going to assume you know what factoring is. It means breaking a number down into multiplication, the product of other numbers. So 24 can be broken down to 2 times 12. But 12 is something we can break down further. So instead of saying 2 times 12, I'm going to say 2 times 2 times 6. But since we can break down the 6 to 2 times 3, I'm not going to say 2 times 2 times 6, but 2 times what 6 is, which is 2 times, oops, sorry, not 6, but 3. And if we want, we can check. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. Over, and we're going to do the same exact thing for the bottom. 18 is 2 times 9. But I'm not going to write 9 because I know that 9 is 3 times 3, so I'm going to say 2 times 3 times 3. And if I double check this, 2 times 3 is 6. 6 times 3 is 18, and it factors out. Now, the next understanding is that any number divided by itself is equal to 1. So any number on top of itself is 1. This is essentially 1. Sorry, I want to kind of strike through those 2's right there. So 2 over 2 is equivalent to 1. And so is 3 over 3. That is equivalent to 1 as well. So this becomes another 1. So I have 1 and 1. So I got those two 1's. And then we can just simplify it. 1 times 2 times 2 times 1. Right? In other words, 4. Right? 2 times 2 is 4 over, and then 3 times 1 times 1, or just 3. So this fraction reduces down to 4/3. And this is all you're doing in a question that's like number 1. You'll notice that every single number I cancel has a multiplication between it and the next number. There is no addition or subtraction between any of my numbers. If there is addition or subtraction, what I did is impossible. We can't do. So now what we want to do is extend this idea. You'll notice that there's a subtraction here between all of my terms, so I can't just start canceling. So what I want to do is I want to find some products, some multiplication. The best thing to do is to factor it out. So we're going to factor out the top. So I find out what they have in common. They both can be divided by 12, so I'm going to write down 12. So they have 12 in common. They also, if you write it in descending order, here's the trick for those of you that are having problems with the variables. If you write it in descending order, the last variable is what you're going to have in common. So I'm going to say x to the power of 3. This only works if you write it in descending order. Times, and then I need to figure out what's left. If I divide this by 12, I get 1. And if I take 3 x's, I only have 1x. So I have 1x left. 12 goes into 65 times, so I have x minus 5. And then there's going to be no x's left. Over. And then now I want to factor out the denominator. Think of two things that multiply to 40. We already did this in the last video. That's 8 and 5. So we're going to have x minus 5 and x plus 8. All right. Now, if you remember, I said you can only cancel where there's multiplication, where there's, in other words, where you have factors. So there are two factors on the bottom. That's factor number 1, and that's factor number 2. On the top, the factors are a little bit weird because a binomial, this thing is considered a factor. This is a bunch of factors in there, so you're going to have to break this guy down if you have other monomials. The trick here is that monomials can only cancel monomials. So this thing, which has no addition or subtraction around it, can only cancel things with no addition or subtraction. These two things are identical factors. They both have x minus 5, so I can cancel out that completely, which leaves us 12 x to the power of 3 over x plus 8. Now, some of you want to cancel out the x's. They can't because of this addition right here. Remember, there has to be multiplication between them. There's multiplication here, and there's multiplication here. So this is a legal cancel. Over here, there is multiplication between the 12 and the x, but there's not multiplication between the x and the 8, so it's not going to cancel. Same thing is true about the 12 and the 8 here. That addition prevents us from canceling it. Or, because this is a binomial, it'll never cancel with parts of the binomial parts will never cancel with an entire monomial. This is our simplified form. If you have any questions, go ahead and give me an email or hit me up on Google Classroom. Until the next video, I'll see you.